This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Ever wondered about the physics behind a bungee jump? It's more than just a thrill ride, you know?
Exactly. It's a fantastic example of energy transformations, yeah.
So we're diving into this bungee jump simulation, exploring energy, forces, and even the G-forces the jumper experiences.
Sounds like fun. We'll be looking at how different factors like the cord's stiffness and the jumper's mass affect the jump.
And how to make sure the jumper doesn't meet an unfortunate end. So let's start with the energy. What are the key players here?
Mainly gravitational potential energy, kinetic energy, and elastic potential energy. As the jumper falls, gravitational potential energy converts to kinetic energy.
Right, speed increases. Then what happens when the bungee cord starts to stretch?
The kinetic energy starts transferring into elastic potential energy, stored in the stretched cord. It's like an energy swap, you know?
And what about the forces? What's acting on the jumper?
Gravity is the main one, pulling the jumper down. Then there's the upward force from the bungee cord resisting the fall.
So it's a tug-of-war between gravity and the bungee cord, right?
Precisely. The simulation lets you see these forces visually, which is really helpful.
This simulation is pretty cool. You can adjust a bunch of things, right?
Absolutely. You can change the height of the jump, the stiffness of the cord's length, and even the jumper's mass.
So you can experiment to find the perfect setup for a safe jump.
Exactly. It's all about finding the right balance between these factors.
What kind of parameters make for a safe jump?
It's a trial and error process. You need to find the minimum platform height that prevents the jumper from hitting the ground.
And what happens if you get it wrong?
Well, the simulation shows a red cross, indicating a less than ideal outcome.
What happens if you change things like the jumper's mass or the cord's length?
Changing the mass or the cord's length significantly impacts the jump's safety. A heavier jumper needs a longer or stiffer cord.
And what about the cord's stiffness?
A stiffer cord, higher K value, means a more abrupt stop, potentially leading to higher G-forces.
The simulation shows G-forces. What's the significance of those?
G-forces represent the acceleration the jumper experiences. High G-forces can be dangerous, even fatal.
So it's not just about not hitting the ground, but also about the forces involved.
Exactly. The simulation helps them understand the relationship between these factors and the resulting G-forces.
So after running the simulation with safe settings, what should we look for?
Observe the energy changes. Ideally, total energy should remain constant, ignoring minor energy losses.
And what about the G-forces?
Analyze the G-force plot to see if the values are within a safe range.
The simulation suggests some further experiments, right?
Yes, it suggests exploring the effects of changing the jumper's mass, cord length, and stiffness on the jump safety.
Like, what adjustments would a jump operator make for a heavier jumper?
They'd likely need to adjust the cord length or stiffness to ensure a safe jump.
The simulation also poses some specific challenges, like finding the longest safe cord length for a given stiffness.
Yes, and finding the least stiff spring for a given cord length. These scenarios help solidify understanding.
And comparing the right experiences based on G-forces.
The comparison highlights how different parameters affect the jumper's experience.
The document also includes learning goals and teacher instructions.
Yes, it provides guidance on using the applet effectively in an educational setting. It's well-structured.
And it explains how to use the different views and controls within the simulation.
The instructions are clear and concise, making it easy for teachers to integrate the simulation into their lessons.
There's also a section on embedding the simulation into a web page.
That's a great feature, making it easily accessible for students.
And it includes credits and information about the license.
Always important to give credit where credit is due. Overall, this bungee jump simulation is a fantastic tool for learning about energy, forces, and safety.
That was a great discussion. Thanks for sharing your insights.